Alright, so going from the little drawing I kind of made, I put 2 points inside of the just basic points, a 180 and a 0. I had them both move 10 and 10. Now this will give me basically an angle of how far to move to 0. By doing this, we go through the mathematics, this, and it gives us our little bit of movement. So it tells us to move at 180. Now the problem with this is it starts getting really complicated. This is the first angle, and by doing the first angle it works, but everything gets rounded off weird and stuff like that, so by the 5th or 6th time, 7th or 8th time through, the answers don't line up as well as I would like them to. They'll be like 2-3 degrees off, and when you're moving 20-30 inches it adds up. So I kind of scrapped that idea. So my first time doing that, it was really complicated mathematics, so I kind of simplified it into individual triangles just on the coordinate system. So basically I took our point and we got our distance, and then what I wanted to find was the x and the y. How far it moved x, how far it moved y. The things we did know though is we knew that the hypotenuse equaled that, which was completely just irrelevant because I already had the hypotenuse. It was the distance. Now we also knew the angle of movement. The angle of movement was basically what the robot was given to move at. So if it was a 30 degrees, it would move to the 30 degrees. And what we wanted to use, or what I chose to use, was the law of sines. And so basically we have this triangle. And this triangle has an A, a B, and a C. We already know C, and we know the C angle, which is always going to be at 90 degrees because we're going off the axes. We know B because we have the angle of movement, and we're going to subtract that from 90, and that's going to give us our B. And then triangles are always 180 degrees, so A, subtract out the B plus C, and that equals A from 180. And then from there, we're going to use this formula to find how far basically x is. So C divided by the sine of C plus the sine of A, or divided by the sine of A, equals how far this x movement is. And now where I had problems was I didn't know if it 100% went on the x and the y if it gave you a negative number. So I kind of have some checkers in there that check if it's negative, check if it's this. So I kind of separated it out. But all in all, you do the same thing with the B. So you had to find the A before you could find the B. And then I added them horizontally and vertically. So I added everything together, and then that's what I sent to the machine again by using the law of cosines, which basically gave my angle on the hypotenuse. And then I do the exact same thing for every other point. So you got your A and your B, your C, and the angles. And so by doing that and just keeping on adding the horizontal and vertical movements of the A and the B, you can then figure out how far your robot's actually moving a certain distance. As for the angle, you take whatever distance they're moving north, south, east, and west, and then convert it out into the angle. Alright, so for my first idea, I was going to use the law of cosines to calculate basically the angle. So what we got is our triangle. We go up this far and down this far. And what we want to find is the distance of travel and also the angle of travel. So what I was going to do is we know A and we know B from our directions. We also know the angle of travel they're at. So what then we're going to find is we're going to find the C and we're going to find X. So first thing we know is A goes this way. And we're going to make our own little graph to go from the vertex so it's a little bit easier. And what we're trying to find is we know that angle because we know X. So because we know the top angle, we need to find X, and that'll give us our distance of travel, and we can use the law of cosines to do the X and the Y up and down, and that'll give us our partial angle. And then we do the other way, we find out how far it goes down, and we're going to find Y. And X plus Y equals C. So by using this information, we can now determine that X equals the square root of A squared plus B squared minus 2AB cosine C. If you don't know what I'm talking about, just go to the law of cosines, and that gives you your directional travel for X. And now what we want to find is we want to find B. Now the thing about B is we already know some of our angles. That angle right up from there is already found out, and B, we can use the law of cosines again to find what B is, just reverse it around. So B plus that little weird number X, or the little arrow, equals the angle of travel. And now from this point, all you got to do is keep repeating it for every time you get another point, because you'll be starting at that location, the new location now. We're going to call this O. And by using O, and let's say we went to Z, this new location, so we went up this far, or whatever happened. I kind of did that wrong here. We're going to have a new triangle. That new triangle is going to be from this one to this one. So we input the new points, put that in, and do all that. This is A list, attempt 1. This is B list, attempt 1. Alright, well that doesn't work. This is C list, attempt 1. This is D list, attempt 1. Alright, so from what I can see, we're getting the third and fourth quadrant wrong. Alright, we're in my test program where I'm testing out the angle and seeing what the results are. So I have our list. This is the B list, which should be in the third quadrant. When I click run, it says my angle is in quadrant 2, which explains why that ends up over there. Alright, so I redid some of the formulas, and from what I was forgetting was an absolute value sign, because if you have a negative, it puts it on the opposite coordinate plane, which would explain why 3 and 2s and usually 4s can be opposite angles. So if we run it again, the same B list, we're now going at the 210 degree angle, which makes perfect sense because it is in the third quadrant. So now we'll retry the robot. Alright, absolute value modified B list. And perfect. Alright, so this is the absolute value D list. And we were going a little far. And I figured out what that was. It was basically me entering in the number of points twice. Now that I only entered it once, it now works just fine. Just a recheck on if absolute value C list will work. And it works just fine. And now we're on to absolute A list. Since all the angles and values work correctly, I just need to wait for Lucas to offer basically the angled points to see if they work with the triangle, but I have tried a couple of them and they seem to be going in the right direction. We'll see when he gives me the actual list.